In this video, we'll show how to use Glycan Reader and Modeler to build a fully glycosylated model of SARS-CoV-2 spike protein in complex with human angiotensin converting enzyme 2, or ACE2. You can download the initial PDB structure and glycan sequences we use by clicking the links in the video description. Let's start by going to Input Generator and then Glycan Reader and Modeler. Select the partially glycosylated structure we provided and choose the PDB format. Click Next Step. On this page, you can see 4 chains identified by PDB Reader. Chains A, B, and C are 3 protomers of the spike protein, and chain D is ACE2. Some glycosylation sites have glycans attached, but they are truncated to at most 3 residues from the reducing terminal. Keep all chains and glycans selected and click Next. In the Glycosylation Options section, click Edit to modify the pre-existing glycan sequence. In the pop-up window, you can load a new glycan sequence in GRS format. Click Upload GRS, input the Glycan Reader sequence, and click Apply. The carbohydrates graph representation will be automatically updated, and you can check whether the glycan sequence is correct. After clicking Next, you can see that the glycan sequence has changed. Alternatively, you can modify the glycan sequence by adding and removing glycan residues in the glycan sequence area. Click plus to add a new residue, and change the residue name and linkage type. Add residues one by one until the glycan sequence is complete. If you want to add chemical modifications, check the Chemical Modification option. Select the residue ID, modification name, and site. Since we don't need chemical modifications here, uncheck this option to remove all modifications, and then click Next. To add a glycan to an unoccupied glycosylation site, click Add Glycan, and a new entry will appear at the end of the list. You can remove it by clicking the minus button. Click the Edit button and upload the GRS in the pop-up windows. Remember to modify the protein chain ID, residue name, and residue number of the glycosylation site. Here, we added an N-linked glycan. Next, we will add an O-linked glycan. In the pop-up windows, upload the GRS and modify the chain ID, residue name, and residue number. When the residue name is changed to serine or threonine, Glycan Modeler will automatically recognize it as an O-linked glycan. Then, add or modify other glycans. Please note that there will be no more audio until 8 minutes and 28 seconds. When all glycans are added, confirm whether the glycan sequences are correct and click Next. Glycan Modeler will build all glycans, and it will take about 30 minutes. Make sure to save your job ID so you can return to your job later with Job Retriever. After several minutes, check your job status with Job Retriever. Enter the job ID and click Submit. Then go to Step 3. If your job has not yet finished, you'll see a message at the bottom saying that the CHARMM-GUI process is still running. In that case, you need to check again in a few minutes. Otherwise, your screen should look like this. You can view the original and final structures by clicking View Structure. If you only want the protein complex manipulated by PDB Reader, then you can download your project and stop here. If you instead want to build a solution system, then enter your solvent settings on this page and click Next.